Assalamualaikum and good day, student. This is chapter 3, lecture 13. This video will mainly focus on the instantaneous center of zero velocity. So what is instantaneous center of zero velocity? The basic idea is in a 2D body plane motion, there is a point either on or off the body about the body rotates. So let's consider this blue rigid body at point A and point B over here. Point A is having a velocity in that direction, meanwhile point B is having a velocity in this direction. So it seems like the point A and point B is having a angular velocity with its center of rotation, where point of rotation at point C. So when the rigid body is moved to the another point, so the zero velocity point is remain at point C. So that is the understanding of instantaneous center of zero velocity. So how to locate the instantaneous center of zero velocity? There is three cases over here, which is vector VA and VB in different direction. So VA and VB is in different direction, whereas for point B over here, VA and VB is in the same direction. Meanwhile, for case C over here, VA and VB is in the opposite direction. Alright, so let's see how to locate the instantaneous center for case A. This is the vector VA pointing downward, and then this is the vector of VB is pointing in this direction. So in order to locate the instantaneous center of a zero velocity, so what you need to do is you need to draw a line perpendicular to VB. So perpendicular to VB means that is the 90 degree from the velocity and the line. So draw all along the way, and then the second one is draw a line perpendicular to VA. So this is the second line, and then the intersection line. So at point C, this is actually the instantaneous center of zero velocity. Okay, let's see on case B, where vector VA and vector VB is in the same direction. So the first thing first is draw the line perpendicular to VA and VB. So draw a line perpendicular to point A and point B. Knowing the magnitude of velocity VA and magnitude of velocity VB, so you need to draw a line connecting the tips of vector VA and VB. Let's say you know this one is 10 meter per second, and then this is 5 meter per second. So at the tips of the arrow over here, you draw a line by crossing the intersection of the line is actually the instantaneous center of zero velocity. Case C, where the vector A and vector B is in the opposite direction. So again, knowing the again you need to draw the line perpendicular to the point VA and VB, and then from the tips of the arrow head A and B, knowing the magnitude of VA and VB, so you need to draw the line crossing the another line, and then the intersection of line is actually your instantaneous center of zero velocity. So this is an example to determine the instantaneous center of zero velocity. Okay, determine the location of instantaneous zero velocity for link BC. They are asking to seek the instantaneous center for link BC. Right. So before that, the link AB is having angular velocity clockwise. Of course, piston C will be moving to the right hand side. Okay, point B has a velocity VB. Point B has a velocity of VB pointing in this direction. So move circular paths and so on. So this one, point C, is on the right hand side. So the motion of point B caused the piston to move forward horizontally. So this is the one, VC. So this is VB. So by drawing the line at point VB over here, 90 degree, 90 degree perpendicular to this velocity, and then at this point also 90 degree, so you can locate the IC. So this one you call it radius of B, instantaneous radius of B, instantaneous radius of C. So this is the one. Alright, so you know that it seems like this one is moving with the angular velocity. So you already locate the point of instantaneous center. So this is the point of instantaneous center. Okay, now let's continue on the example 2. So given the question over here, block D is moved with the speed of this is block D, is moved to the right hand side with a speed of 3 meters per second. So you need to determine the velocity of link BD and link AB. So these two link, you need to identify the angular velocity. As D move to the right, so it will cause AB to rotate clockwise. Correct. Okay, this is omega about point A, because this is a fixed axis. Hence VB is directed perpendicular to AB. So means that there is a velocity over here acting perpendicular to the AB. So this is 90 degree. The instantaneous center of zero velocity for BD here is located at the intersection of the line segment drawn perpendicular to VB and VD. So we draw a line perpendicular to VB and VD. So this is VB. We need to draw a line over here, 90 degree. Okay, drawn. And then from D over here, again draw a line perpendicular to VD, because this is VD. To draw a line, so means that this is the R instantaneous radius of point D, instantaneous radius of point C, point B, sorry, instantaneous radius at point B. Okay, so this is the instantaneous center IC. Alright, so from geometry, knowing that from geometry you can reveal the length of this one, and also you can reveal the dimension of instantaneous radius from point point D to the instantaneous center. And then since you know that VD, since the magnitude of VD is known, so VD is already known, and then the angular velocity of link BD can be revealed from this equation. So you can get the answer over here. Alright. The next question is asking you to get the omega AB. Just now we already know the omega BD. So now they're asking you to get the omega AB. So by using this formula and putting the previous result that you get, so you will know that VB is 2.12. From the figure, the angular velocity of AB is 2.12 divided by 0.4, so you get the angular velocity is 5.30 radian. So this is the velocity of this one, right? So the angular velocity is this one. Alright, thank you very much. Okay, let's see another example over here. If you remember that we are having a problem from the previous lecture. One problem we can solve using 4 different methods. Now we try to solve this problem using instantaneous instantaneous center of zero velocity. If you remember, the question is asking you to get the angular velocity of BC and what is the velocity of C. Alright, giving the rotation of this is A, this is B, and this is C. So the rotation of AB is 100 RPM. So here it will have a velocity of VB, where you can find it from the n given. Okay, knowing that the VB over here is actually 2.09, and then you know that VC is acting downward and then VB is in this direction. To allocate the instantaneous center, so what you need to do is you need to draw a line perpendicular to this VB direction. Draw all along the way, and then the another line is perpendicular to VC. So this intersection is actually the instantaneous center of zero velocity. So from this triangle, so what you can reveal from this equation is that from this sine equation, you can reveal the radius of instantaneous center for point C and radius of instantaneous center for point B. Okay, the next one, from the equation of VC equal to RCIC omega, so omega you don't know, then you need to find. Since the sense of rotational sense of omega BC is the same as rotational caused by VB about BC, meaning that the rotational is in this direction. Okay, and then from this equation you can reveal the angular velocity of VC. Then by having this angular velocity of omega BC, you can put into the equation over here, and then you will get velocity of c is equal to 1.48. Okay, thank you very much.